air pressure losses in pneumatic system. To calculate air pressure losses, this is the formula called Harris formula is used to calculate the air pressure losses. Now C is a constant for a Schedule 40 commercial pipe. The value of C is determined by this equation. Now generally the higher the schedule is, the stronger the pipes are, and all of these schedule 20, 40, 80, or the properties of those pipes can be found in any textbook. Also, they're available online these days. You can simply Google and find their properties. Now, the interesting thing about those pipes, you see that nominal dimension, the pipe that says ½ inch, they're not really ½ inch. Their diameter is actually this for a Schedule 40. So they're not. So when they call nominal pipe size ½ inch, typically their internal diameter. However, you see they're not exactly 0.5, they're a little bit off. Anyway, so this can be found from online because or if from a textbook, we need to use this D in the equation, the diameter. So let's quickly explain this equation. C is a constant that comes from here, that is also associated with diameter. So if you convert that equation, just replacing C, you get this. Now, Q, which is the flow rate, standard cubic feet per second. Standard means 68 degree Fahrenheit or 20 degrees Celsius, and 0 psi gas or atmospheric pressure, simply ATM pressure. Now, CR is the compression ratio. It's one single thing, which is a pressure inside the pipe divided by the atmospheric pressure, and L is the length. Now, to calculate length, we have to also consider fittings like T's, 90-degree elbows, 45. So we have fittings, not just the pipe. So when we calculate friction losses, remember in hydraulics, we have to separately calculate the losses in this. Here, you don't have to. You can simply use this available table for the equivalent length. Now, what is equivalent length? Equivalent length is this. We know that these fittings, they lost more than a straight pipe. So equivalent length is for this T, this type of T. You see that equivalent length given is 4.2. What that means is a 4.2 feet of pipe, a straight pipe, has exact same loss as these connections. So we can simply, if we add 4.2 feet of length with this L, then we are actually accounting this T. So just add all the connections and pipes and then total length, input in this equation. Now in old days, they didn't have fancy calculators. So D power 5.31 is also calculated here. So which you can use. You don't really have to put that in the calculator either. So just calculate the compression ratio, and then flow rate typically will be given. We'll say is flow rate is this mass and the length. And then you can find the compression ratio, which you have to calculate. So the pressure divided by the atmospheric pressure. Now, if it's in FE English system, you simply do PSI, whatever that absolute value is, divided by 14.7 PSI absolute atmospheric pressure. So let's say a compressor is running at 120 PSI. So 120 PSI gas plus 14.7 PSI divided by 14.7. So that would be compression ratio. So I hope this explained how to use this friction loss calculation formula. So this pressure loss. Once we know the pressure loss in a system, we can calculate the horsepower loss and cost and things like that.